Sections 115 to 129 of Berkeley's Treatise. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Heather Jane Hogan. Sections 115 to 129 of A Treatise Concerning the Principles of Human Knowledge, Part 1, by George Berkeley. 115. For to denominate a body moved, it is requisite first that it change its distance or situation with regard to some other body, and secondly, that the force occasioning that change be applied to it. If either of these be wanting, I do not think that, agreeably to the sense of mankind, or the propriety of language, a body can be said to be in motion. I grant, indeed, that it is possible for us to think a body which we see change its distance from some other to be moved, though it have no force applied to it, in which sense there may be apparent motion. But then it is because the force causing the change of distance is imagined by us to be applied or impressed on that body thought to move, which indeed shows we are capable of mistaking a thing to be in motion, which is not, and that is all. 116. From what has been said, it follows that the philosophic consideration of motion does not imply the being of an absolute space distinct from that which is perceived by sense and related bodies, which that it cannot exist without the mind is clear upon the same principles that demonstrate the like of all other objects of sense. And perhaps, if we inquire narrowly, we shall find we cannot even frame an idea of pure space exclusive of all body. This, I must confess, seems impossible, as being a most abstract idea. When I excite a motion in some part of my body, if it be free or without resistance, I say there is space. But if I find a resistance, then I say there is body. And in proportion as the resistance to motion is lesser or greater, I say the space is more or less pure. So that when I speak of pure or empty space, it is not to be supposed that the word space stands for an idea distinct from or conceivable without body and motion, though indeed we are apt to think every noun substantive stands for a distinct idea that may be separated from all others, which has occasioned infinite mistakes. When, therefore, supposing all the world to be annihilated besides my own body, I say there still remains pure space, thereby nothing else is meant, but only that I conceive it possible for the limbs of my body to be moved on all sides without the least resistance. But if that too were annihilated, then there could be no motion, and consequently no space. Some, perhaps, may think the sense of seeing doth furnish them with the idea of pure space, but it is plain, from what we have elsewhere shown, that the ideas of space and distance are not obtained by that sense. See the essay concerning vision. 117. What is here laid down seems to put an end to all those disputes and difficulties that have sprung up amongst the learned concerning the nature of pure space. But the chief advantage arising from it is that we are freed from that dangerous dilemma to which several who have employed their thoughts on that subject imagine themselves reduced, to wit, of thinking either that real space is God, or else that there is something beside God which is eternal, uncreated, infinite, indivisible, immutable. Both which may justly be thought pernicious and absurd notions. It is certain that not a few divines, as well as philosophers of great note, have, from the difficulty they found in conceiving either limits or annihilation of space, concluded it must be divine, and some of late have set themselves particularly to show the incommunicable attributes of God agree to it. which doctrine, how unworthy soever it may seem of the divine nature, yet I do not see how we can get clear of it, so long as we adhere to the received opinions. 118. Hitherto of natural philosophy, we come now to make some inquiry concerning that other great branch of speculative knowledge, to wit, mathematics. These, how celebrated soever they may be for their clearness and certainty of demonstration, which is hardly anywhere else to be found, cannot nevertheless be supposed altogether free from mistakes, if in their principles there lurks some secret error which is common to the professors of those sciences with the rest of mankind. Mathematicians, though they deduce their theorems from a great height of evidence, yet their first principles are limited by the consideration of quantity, and they do not ascend into any inquiry concerning those transcendental maxims which influence all the particular sciences, each part whereof, mathematics not excepted, does consequently participate of the errors involved in them. That the principles laid down by mathematicians are true, and their way of deduction from those principles clear and incontestable, we do not deny. But we hold there may be certain erroneous maxims of greater extent than the object of mathematics, and for that reason, not expressly mentioned, though tacitly supposed throughout the whole progress of that science, and that the ill effects of those secret unexamined errors are diffused through all the branches thereof. To be plain, we suspect the mathematicians are as well as other men concerned in the errors arising from the doctrine of abstract general ideas and the existence of objects without the mind. 119. Arithmetic has been thought to have for its object abstract ideas of number, of which to understand the properties and mutual habitudes is supposed no mean part of speculative knowledge. The opinion of the pure and intellectual nature of numbers in abstract has made them in esteem with those philosophers who seem to have effected an uncommon fineness and elevation of thought. It hath set a price on the most trifling numerical speculations, which in practice are of no use, but serve only for amusement, and hath therefore so far infected the minds of some, that they have dreamed of mighty mysteries involved in numbers, and attempted the explication of natural things by them. But if we inquire into our own thoughts, and consider what has been premised, we may perhaps entertain a low opinion of those high flights and abstractions, and look on all inquiries about numbers only as so many difficile nugae, so far as they are not subservient to practice and promote the benefit of life. 120. Unity in abstract we have before considered in section 13, from which and what has been said in the introduction, it plainly follows there is not any such idea. But, number being defined a, quote, collection of units, unquote, we may conclude that, if there be no such thing as unity or unit in abstract, there are no ideas of number in abstract denoted by the numeral names and figures. The theories, therefore, in arithmetic, if they are abstracted from the names and figures, as likewise from all use and practice, as well as from the particular things numbered, can be supposed to have nothing at all for their object. Hence, we may see how entirely the science of numbers is subordinate to practice, and how jejune and trifling it becomes when considered as a matter of mere speculation. 121. However, since there may be some who, deluded by the specious show of discovering abstracted verities, waste their time in arithmetical theorems and problems which have not any use, it will not be amiss if we more fully consider and expose the vanity of that pretense, and this will plainly appear by taking a view of arithmetic in its infancy, and observing what it was that originally put men on the study of that science, and to what scope they directed it. It is natural to think that at first men, for ease of memory and help of computation, made use of counters, or in writing of single strokes, points, or the like, each whereof was made to signify a unit, i.e., some one thing of whatever kind they had occasion to reckon. Afterwards, they found out the more compendious ways of making one character stand in place of several strokes or points. And, lastly, the notation of the Arabians or Indians came into use, wherein, by the repetition of a few characters or figures, and varying the signification of each figure according to the place it obtains, all numbers may be most aptly expressed, which seems to have been done in imitation of language, so that an exact analogy is observed betwixt the notation by figures and names, the 9 simple figures answering the 9 first numeral names and places in the former, corresponding to denominations in the latter. And agreeably to those conditions of the simple and local value of figures, we contrived methods of finding from the given figures or marks of the parts, what figures and how placed are proper to denote the whole, or vice versa. And having found the sought figures, the same rule or analogy being observed throughout, it is easy to read them into words, and so the number becomes perfectly known. For then the number of any particular things is said to be known, when we know the name of figures, with their due arrangement, that according to the standing analogy belong to them. For these signs being known, we can by the operations of arithmetic know the signs of any part of the particular sums signified by them, and thus computing in signs, because of the connection established between them, and the distinct multitudes of things whereof one is taken for a unit, we may be able rightly to sum up, divide, and proportion the things themselves that we intend to number. 122. In arithmetic, therefore, we regard not the things, but the signs, which nevertheless are not regarded for their own sake, but because they direct us how to act with relation to things and dispose rightly of them. Now, agreeably to what we have before observed of words in general, section 19, Introduction, it happens here likewise that abstract ideas are thought to be signified by numeral names or characters, while they do not suggest ideas of particular things to our minds. I shall not at present enter into a more particular dissertation on this subject, but only observe that it is evident from what has been said, those things which pass for abstract truths and theorems concerning numbers, are in reality conversant about no object distinct from particular numeral things, except only names and characters, which originally came to be considered on no other account but their being signs or capable to represent aptly whatever particular things men had need to compute. Whence it follows that to study them for their own sake would be just as wise and to as good purpose as if a man, neglecting the true use or original intention and subserviency of language, should spend his time in impertinent criticisms upon words, or reasonings and controversies purely verbal. 123. From numbers we proceed to speak of extension, which, considered as relative, is the object of geometry. The infinite divisibility of finite extension, though it is not expressly laid down either as an axiom or theorem in the elements of that science, yet is throughout the same everywhere supposed and thought to have so inseparable and essential a connection with the principles and demonstrations in geometry, that mathematicians never admit it into doubt, or make the least question of it. And as this notion is the source from whence do spring all those amusing geometrical paradoxes which have such a direct repugnancy to the plain common sense of mankind, and are admitted with so much reluctance into a mind not yet debauched by learning, so it is the principal occasion of all that nice and extreme subtlety which renders the study of mathematics so difficult and tedious. Hence, if we can make it appear that no finite extension contains innumerable parts, or is infinitely divisible, it follows that we shall at once clear the science of geometry from a great number of difficulties and contradictions which have ever been esteemed a reproach to human reason, and withal make the attainment thereof a business of much less time and pains than it hitherto has been. 124. Every particular finite extension which may possibly be the object of our thought is an idea existing only in the mind, and consequently each part thereof must be perceived. If, therefore, I cannot perceive innumerable parts in any finite extension that I consider. It is certain they are not contained in it. But it is evident that I cannot distinguish innumerable parts in any particular line, surface, or solid, which I either perceive by sense or figure to myself in my mind. Wherefore I conclude they are not contained in it. Nothing can be plainer to me than that the extensions I have in view are no other than my own ideas, and it is no less plain that I cannot resolve any one of my ideas into an infinite number of other ideas, that is, that they are not infinitely divisible. If by finite extension be meant something distinct from a finite idea, I declare I do not know what that is, and so cannot affirm or deny anything of it. But if the terms extension, parts, etc., are taken in any sense conceivable, that is, for ideas, then to say a finite quantity or extension consists of parts infinite in number is so manifest a contradiction that every one at first sight acknowledges it to be so, and it is impossible it should ever gain the assent of any reasonable creature who is not brought to it by gentle and slow degrees, as a converted Gentile to the belief of transubstantiation. Ancient and rooted prejudices do often pass into principles, and those propositions which once obtain the force and credit of a principle are not only themselves, but likewise whatever is deductible from them, thought privileged from all examination. And there is no absurdity so gross, which, by this means, the mind of man may not be prepared to swallow. 125. He whose understanding is possessed with the doctrine of abstract general ideas may be persuaded that, whatever be thought of the ideas of sense, extension in abstract is infinitely divisible. And one who thinks the objects of sense exist without the mind will perhaps in virtue thereof be brought to admit that a line but an inch long may contain innumerable parts, really existing, though too small to be discerned. These errors are grafted as well in the minds of geometricians as of other men, and have a like influence on their reasonings, and it were no difficult thing to show how the arguments of geometry made use of to support the infinite divisibility of extension are bottomed on them. At present we shall only observe in general whence it is the mathematicians are so fond and tenacious of that doctrine. 126. It hath been observed in another place that the theorems and demonstrations in geometry are conversant about universal ideas, section 15, Introduction, where it is explained in what sense this ought to be understood, to wit, the particular lines and figures included in the diagram are supposed to stand for innumerable others of different sizes, or, in other words, the geometer considers them abstracting from their magnitude, which does not imply that he forms an abstract idea, but only that he cares not what the particular magnitude is, whether great or small, but looks on that as a thing different to the demonstration. Hence it follows that a line in the scheme but an inch long must be spoken of as though it contained 10,000 parts, since it is regarded not in itself, but as it is universal, and it is universal only in its signification, whereby it represents innumerable lines greater than itself, in which may be distinguished 10,000 parts or more, though there may not be above an inch in it. After this manner, the properties of the lines signified are, by a very usual figure, transferred to the sign, and thence, through mistake, though to appertain to it considered in its own nature. 127. Because there is no number of parts so great, but it is possible there may be a line containing more, the inch line is said to contain parts more than any assignable number, which is true, not of the inch taken absolutely, but only for the things signified by it. But men, not retaining that distinction in their thoughts, slide into a belief that the small particular line described on paper contains in itself parts innumerable. There is no such thing as the 10, 10,000th part of an inch, but there is of a mile, or diameter of the earth, which may be signified by that inch. When, therefore, I delineate a triangle on paper, and take one side not above an inch, for example, in length to be the radius, this I consider as divided into 10,000 or 100,000 parts or more. For though the 10,000th part of that line considered in itself is nothing at all, and consequently may be neglected without an error or inconveniency, yet these described lines, being only marks standing for greater quantities, whereof it may be the 10,000th part, is very considerable, it follows that, to prevent notable errors in practice, the radius must be taken of 10,000 parts or more. 128. From what has been said, the reason is plain why, to the end any theorem become universal in its use, it is necessary we speak of the lines described on paper as though they contained parts which really they do not. In doing of which, we examine the matter thoroughly, we shall perhaps discover that we cannot conceive an inch itself as consisting of, or being divisible into, 1,000 parts, but only some other line which is far greater than an inch and represented by it, and that when we say a line is infinitely divisible, we must mean a line which is infinitely great. What we have here observed seems to be the chief cause why to suppose the infinite divisibility of finite extension has been thought necessary in geometry. 129. The several absurdities and contradictions which flowed from this false principle might, one would think, have been esteemed so many demonstrations against it. But, by I know not what logic, it is held that proofs a posteriori are not to be admitted against propositions relating to infinity, as though it were not impossible even for an infinite mind to reconcile contradictions, or as if anything absurd and repugnant could have a necessary connection with truth, or flow from it. But whoever considers the weakness of this pretense will think it was contrived on purpose to humor the laziness of the mind, which had rather acquiesce in an indolent skepticism than be at the pains to go through with a severe examination of those principles it has ever embraced for true. End of sections 115 to 129 of A Treatise Concerning the Principles of Human Knowledge, Part 1, by George Berkeley. Recording by Heather Jane Hogan of redheadhogan.com.